Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an oblique pentagonal pyramid of base edge 30 mm and axis height 50 mm long, and this pentagonal pyramid is positioned with respect to horizontal plane in such a way that it is resting on one of its corners of its base onto the ground, when the triangular face opposite to this particular corner, it happens to be parallel to the horizontal plane. So here let us first of all evaluate that which one of these two orientations of the pentagonal pyramid will be appropriate, as the pentagonal pyramid is resting onto the horizontal plane. Now please see, if we assume that this is going to be the orientation of the pentagonal pyramid onto the horizontal plane. Now if I tilt this pentagonal pyramid, now it will be resting on the horizontal plane on one of its corners, so it is going to satisfy first condition. But the moment I tilt this pentagonal pyramid with respect to horizontal plane, there will be no opposite triangular face which will be parallel to the horizontal plane over here, because this opposite triangular face, it will be inclined to the horizontal plane. So this orientation of the pentagonal pyramid with respect to horizontal plane is incorrect. If we are going to assume that we are going to locate pentagonal pyramid onto the horizontal plane in this orientation, now you see, if I tilt this particular pentagonal pyramid like this, so it will be resting on horizontal plane on one of its corners of its base, and if I tilt it up to this extent, now this triangular face which is opposite to this particular corner, so I can tilt it in such a way that this triangular face can become parallel to the horizontal plane. So this way, this is the correct or appropriate orientation of the pentagonal pyramid with respect to the horizontal plane. Now once I tilt this pentagonal pyramid like this, such that it is resting onto the ground on one of its corners of its base, and this triangular face of this particular pentagonal pyramid which happens to lie opposite to this corner, so this becomes parallel to the horizontal plane. Now in the second orientation, I have been provided with another information that this edge, you can see, it is this edge. So once this face is parallel to the horizontal plane, so this edge will be appearing as a true length onto the top view projections over here. Now this edge of this particular slant face which is appearing as a true length onto the top view projections after the first inclination, so this edge of the base, it is further inclined at an angle of 60 degree with respect to the vertical plane. So this way, this pentagonal pyramid is first inclined with respect to horizontal plane, and thereafter this edge, it is further inclined with respect to vertical plane at an angle of 60 degree. So we have got a pentagonal pyramid which is inclined to both the horizontal plane as well as the vertical plane. So this is the case of an oblique pentagonal pyramid, and we are required to obtain the orthographic projections of this oblique pentagonal pyramid. So let us proceed with the construction of the orthographic projections of a pentagonal pyramid when this pentagonal pyramid happens to lie onto the horizontal plane onto its base over here. So once we are going to look at this pentagonal pyramid from the top, so we find that one of the edge of the base of this pentagonal pyramid, so this will be perpendicular to the vertical plane. Why? Because this is the corner onto which the pyramid will be resting onto the ground, and this face, it will be moved in such a way that this slant face, this triangular slant face will become parallel to the horizontal plane after the first inclination of this pentagonal pyramid with respect to the horizontal plane. So now we have marked these points A, B, C, D, E, and the edge of the pentagonal pyramid we have taken as 30 millimeter. Now we need to obtain the axis point. In order to obtain the axis point of this pentagonal pyramid, we need to draw perpendicular bisectors from each of the corners onto the opposite edges of this pentagonal pyramid over here. So from point D, we will draw a perpendicular bisector of the edge AB. From E, we are going to draw a perpendicular bisector of the edge BC over here. From corner A, we are going to draw a perpendicular bisector of the edge CD over here, and from point B we are going to draw a perpendicular bisector of the edge DE over here. So this way, from each one of the corners of this pentagonal pyramid, we have drawn the perpendicular bisectors over here. So wherever these 5 perpendicular bisectors they have intersected, so this is my location of the axis point. So I can write down O and O1 over here. So O point corresponds to the apex, while O1 point corresponds to the axis point which is going to lie onto the base of this pentagonal pyramid. Now we need to join all the slant edges, slant edge 1, slant edge 2, slant edge 3, slant edge 4 and slant edge 5. So let us join all the slant edges. So OA, OB, OC, OD and OE slant edges we have joined over here. So this completes the construction of top view projection of the pentagonal pyramid. Now let us proceed with the construction of the front view projections of this pentagonal pyramid. So the axis point we have already located. So from the axis point O1 we have shown the axis over here. So we know that the height of the axis is 50 millimeter. Now since this pentagonal pyramid is resting onto the base on the horizontal plane, so points B and A, they will be observed as B dash and A dash onto the XY reference line onto the ground. Similarly, points C and D, they will be represented as C dash and E dash onto the XY reference line, that is they will also be lying onto the ground. And finally point D, it will be projected as point D dash onto the XY reference line or onto the ground. So the axis point of the base we have marked as O1 dash. Now we know the axis height. This is equal to 50 millimeter. The moment we mark this axis height as 50 millimeter, so this point O corresponding to apex we have already identified. So the moment we identify this point O dash over here, now we can join O dash, B dash and O dash A dash. We can join O dash C dash and O dash E dash, and we can join the slant edge O dash D dash over here. Here we need to remember that edge OA, since it is lying at the back, it should have appeared as a hidden line or a dotted line over here in the front view projection. But this projection O dash A dash, which is a hidden line projection, it has been superseded or overlapped by the object line projection corresponding to the slant edge OB over here. So that is why we are not able to see any hidden line projection corresponding to O dash A dash in the front view projection. Similarly, OE slant edge is also lying on the back side. So we should have obtained O dash E dash as the hidden line or the dotted line projection in the front view projection over here. But this hidden line O dash E dash projection has been superimposed by this slant edge projection that is corresponding to OC. So O dash C dash, it is the object line projection because this slant edge is visible to the observer. So O dash C dash projections, they are going to supersede or overlap hidden line projections corresponding to the slant edge O dash E dash over here. So now we have been able to obtain the front view projections of the pentagonal pyramid when this pentagonal pyramid happens to lie on the base into the horizontal plane. Now we know that we have to tilt this particular pentagonal pyramid in this orientation such that it should be resting on one of its corners of the base onto the ground, onto the horizontal plane, while this slant face, this triangular slant face, that is O dash, B dash and A dash, this one, O dash, A dash and B dash, this slant face should become parallel to the horizontal plane. So what we are required to do? We are required to transform or rotate this particular front view projection in such a way that this slant face O dash, B dash, A dash, corresponding to which we have obtained an edge view over here. So this edge view of the triangular slant face, it should become parallel to the horizontal plane, while this particular pentagonal pyramid should be resting on the point D dash onto the horizontal plane. Now here you can see, in order to transfer this figure, we have to use the principle of rectilinear distances. And now how we are going to transfer this figure? In order to facilitate easy rotation or transfer of this front view projection into the new orientation over here, what we have to do? We have to draw a perpendicular projector from point D dash onto this slant face, which is O dash, B dash and A dash over here. Once we draw this perpendicular projector from D dash onto the slant triangular face O dash, A dash and B dash over here, so this point we are going to obtain as point P dash. So once we obtain this point P dash, now we know this is the perpendicular distance from point D dash onto this slant face. So how we are going to transfer this front view elevation projection? Now over here we are going to assume at a certain point that there is going to be point D dash lying over here. So this point we are going to assume this point name will be D1 dash. So the name of this point is D1 dash. So once I draw this point over here, so it means that I am going to rotate this front view elevation projection of this pentagonal pyramid in such a way that it will be resting on one of its corners of its base onto the horizontal plane. Now I know this edge length over here, that is an imaginary edge length. This is D dash P dash. So this distance is known to me. So I have drawn this distance is equal to D1 dash P1 dash. So D1 dash P1 dash, this is a perpendicular projector which we have drawn from the point D1 dash over here. Now once we draw this perpendicular projector, I know that this perpendicular projector, it is perpendicular to this particular face, which happens to be a triangular face O dash, A dash, B dash. So from this point, if I draw a perpendicular projector line over here, so I know this distance from P dash to B dash A dash. I know this distance from P dash to O dash. So from P1 dash, I'll measure this distance P dash to B dash A dash. So I'll be able to locate the points A1 dash and B1 dash over here. Similarly, I know the distance from P dash to O dash. Now since this surface or the triangular face happens to be perpendicular to this edge, so the moment I draw a perpendicular projector over here and measure these two distances over here, so this triangular face I have been able to obtain parallel to the horizontal plane. So O1 dash has been located, A1 dash has been located, B1 dash has been located. So the moment I am able to locate these points, now I can join D1 dash with A1 dash, B1 dash. I can also join D1 dash with O1 dash. So this way I have been able to transfer or rotate this front view projection from the original upright position into a new position in which the pentagonal pyramid is inclined with respect to the horizontal plane in such a way that it is resting onto the ground on one of its corners of its base, while this triangular face opposite to this corner. This is a triangular face which happens to be opposite to this corner. So this triangular face happens to be parallel to the horizontal plane. So now I have evaluated the distance between D1 dash and A1 dash B1 dash. Now once this edge has been defined, so now if I measure these two distances, that is the distance of D dash from C dash E dash, distance of D dash from O1 dash over here. So 2 points I can mark over here. So the moment I mark these 2 points, so the entire pentagonal pyramid front view projection has been translated or rotated from the current upright position into the new inclined position, where one of the triangular faces opposite to the base corner, it happens to be parallel to the horizontal plane. Now having obtained all the points into the new orientation, now what I can do, I can join all the points of the elevation projection view corresponding to this inclined pentagonal pyramid, in which this triangular face happens to be parallel to HP and it is resting on one of its corners of its base onto the horizontal plane. Now once I have obtained the front view projections corresponding to this inclined pentagonal pyramid, I need to obtain the corresponding top view projections corresponding to this particular inclined pyramid with respect to the horizontal plane. So how that can be done? How many points are available with me in the front view projections? 5 points are available with me corresponding to the base. 2 points are available with me corresponding to the axis point. So I'm not bothered about this point P1 dash, because this was only the imaginary point which we had created only to facilitate rotation of this pentagonal pyramid front view projections from the upright position into the new position over here. So there are 7 points which are available with me in the front view projections over here. So from all these 7 points, I am going to draw the vertical projector projections, and wherever these vertical projector lines, they are going to intersect with horizontal projector lines which I am going to draw from the previous plan projection view. So the corresponding points of intersection will provide me all the points of the plan projection view corresponding to this inclined pentagonal pyramid. Now let us start with the location of the plan projection points corresponding to this inclined pyramid. So here first point is available with me as point E. So from point E, I have drawn a horizontal projector line. So wherever it intersects with the vertical projector line drawn from point E1 dash, so the intersection point provides me with the location of the point E1 over here. Similarly from the point A, if I draw a horizontal projector line, wherever this horizontal projector line intersects with the vertical projector line drawn through the point A1 dash, I obtain the point A1 in the top view projections over here. So next point is O, O1 and D. So from O, O1 and D, if I draw a horizontal projector line, so onto this horizontal projector line, I am going to find out 3 points. So onto this horizontal projector line, we can see the intersection of the vertical projector drawn through O1 dash. It will provide us with the location of the point O1. Similarly, the intersection of this horizontal line with the vertical projector drawn through the point D1 dash, it will provide us with the location of the point D1. And similarly, since this horizontal projector line was drawn through the point O1, so onto this horizontal projector line, the vertical projector drawn through the point O11 dash. So this intersection will be providing us with the location of the point O11. So 3 points we have been able to locate onto this horizontal line. Now next we have got the point B. So if we draw a horizontal projector line through point B, so the intersection of this horizontal line drawn through the point B with the vertical projector line drawn through the point B1 dash. So this intersection provides us with the location of the point B1 over here. And finally, we have got this point C. So if we draw a horizontal projector line through this point C, so the intersection of this horizontal projector line with the vertical projector line drawn through the point C1 dash. So this is vertical projector line drawn through the point C1 dash. So this intersection provides us with the location of the point C1 over here. So we can see all the 7 points corresponding to this inclined pentagonal pyramid, they have been appropriately located in the top view projection. Now which are the edges we need to join? A1 B1, B1 C1, C1 D1, D1 E1, E1 A1, and also we need to join O1 with A1, O1 with B1, O1 with C1, O1 with D1 and O1 with E1 over here. So which of these edges they will be drawn dark, that is using object line, and which one of these edges they will be drawn using hidden line or the dotted line. So let us evaluate that. Now since the observer is going to look at the solid from the top, so the farthest point from the observer and closest point to the plane is D1 over here, because it is resting on one of its corner. This corner is D1. So this corner is D1. So D1 point is the point which is farthest away from the observer, that is D1 dash. So in the top view, anything joining D1 should be drawn as a dotted line unless it is going to constitute the boundary of the solid. So let us start joining the edges over here. So we can see D1 E1, it is not forming the boundary. So it has been drawn using the hidden line or the dotted line. Similarly, D1 C1, it is again not forming the boundary. So it is not constituting the boundary anymore. So C1 D1 has been drawn using dotted line. Similarly, O1 D1 will also be drawn dotted over here. So these 3 edges, they have been drawn dotted. Rest everything has been drawn using the object line or a darker line. So with this, the top view projections of this inclined pentagonal pyramid have been obtained in the top view projections onto the horizontal plane. And into these projections, we can see this edge. Please check it out. This is the edge. So this edge, because it is parallel to the horizontal plane, so on the horizontal plane, A1, B1 has been represented as true length over here. So A1, B1 has been represented as true length projection onto the top view projection. Now in the second iteration, we have been provided with the information that the edge of the base, which is contained by this triangular face, this is the triangular face, O1 dash, A1 dash, B1 dash, right? So this is the triangular face. You can see O1, A1, B1. This triangular face, it is the true shape as it is represented in the top view projection. Why? Because O1 dash, A1 dash and B1 dash, this triangular face happens to be parallel to the horizontal plane. So this is the true length. Now this edge, it is further inclined with respect to vertical plane at an angle of 60 degree, and the apex should be located towards the observer or away from the vertical plane. So now you can see we have marked this angle. This angle is angle phi. Why this angle will be angle phi? Because onto this orientation, I have to mark the true length of the edge A1, B1 of the base over here. So this edge of the triangular surface, which is parallel to the horizontal plane, it is represented as a true length over here. So this A1, B1 will be represented over here as A2, B2. So since this edge length will be true length, so this angle we can safely assume that this angle of inclination is angle phi. So at angle phi is equal to 60 degree, we have marked this orientation line over here. Now onto this orientation line, this plan projection view, which we have previously obtained, it has to be rotated or transformed over here in such a way that A1, B1 will be located as A2, B2 over here. So here we can see this pentagonal figure has been inscribed into this rectangular shape construction over here. So this is a rectangle which is going to inscribe this pentagonal shape of the base over here. we can transfer this base of the rectangle. You can check this dimension, it is equal to this dimension, and the height, it is the perpendicular dimension over here. So once we have drawn this rectangular construction over here, so we know the distance between this edge and A1, this edge and B1, this edge and C1, this edge and E1, this edge and O1, this edge and D1, and distance between this edge and O1 is also known. So using rectilinear distances, we can see, we can mark all of these points over here. So we can check A1, B1 will be marked as A2, B2. This distance will be marked as C2. Similarly, this distance will be marked as D2. This distance will be marked as E2. This distance will be marked as O21, and this distance will be marked as O2 over here. So this way, using rectilinear distances, all the points, they have been plotted into the plan projection view corresponding to this oblique pentagonal pyramid, which happens to be having a triangular surface parallel to the horizontal plane, and the edge of the base, which is contained by this triangular surface, inclined at an angle of 60 degrees with respect to the vertical plane. So these are the projections of the oblique pentagonal pyramid, which is inclined to HP and inclined to VP. So having obtained the orthographic top view projections of this pentagonal pyramid, which is an oblique pentagonal pyramid, now we need to obtain the front view or the elevation projections of this oblique pentagonal pyramid using the principle of intersection of the corresponding point projector lines over here. So what we are going to do, from these 7 points, because 7 points they are available over here into the plan projection view. Now from these 7 points, we are going to draw vertical projectors in the upward direction into the elevation projection view. And now from the previous elevation projection view, from the 7 points, we are going to draw the horizontal projector lines. So wherever the intersection of the corresponding projection lines will be obtained, so the elevation projection points, they will be obtained corresponding to this oblique solid. So let us proceed with construction of first horizontal projector line. So first horizontal projector line will be emerging from A1 dash, B1 dash and O1 dash. So once we draw first horizontal projector line through A1 dash, B1 dash and O1 dash, now 3 elevation projection points we are going to obtain onto this horizontal line. So when this horizontal projector line will be intersected by vertical projector drawn through the point O2 over here, we will be obtaining the point O2 dash. Similarly, when this horizontal projector line drawn through the point A1 dash, it will intersect with the vertical projector line drawn through the point A2, so we will be obtaining the point A2 dash over here. Similarly, when this horizontal projector line drawn through the point B1 dash, it intersects with the vertical projector line drawn through the point B2 over here, so point B2 dash will be located over here. Next, here we have got point O11 dash. So once we draw a horizontal projector line through O11 dash, wherever it intersects with the vertical projector line drawn through the point O21, so the point O21 dash will be obtained. Next, we have got these 2 points, C1 dash and E1 dash. So once we draw the horizontal projector line through C1 dash and E1 dash, so wherever this horizontal projector line intersects with vertical projector drawn through the point E2, so point E2 dash will be located. Wherever this horizontal projector line will be intersected by the vertical projector line drawn through the point C2 over here, so point C2 dash will be located. And finally, this is point D1 dash onto which the pyramid is resting onto the horizontal plane. So if we draw a horizontal projector through D1 dash, it will be coinciding with the XY reference line. So whenever this horizontal projector line it will be intersected with vertical projector drawn through the point D2 over here. So this point will be located as D2 dash in the front view projections over here. So all these 7 points corresponding to this oblique pentagonal pyramid have been appropriately located in the front view projections over here. So let us evaluate which one of the edges will be drawn as an object line and which one of the edges will be drawn as dotted or the hidden line. So as the observer is going to look at this particular oblique pyramid from this orientation, so the farthest point from the observer is E2 or the closest point to the plane is E2. So anything joining E2 should be drawn as a dotted line or a hidden line unless that edge constitutes the boundary of the solid. So let us start joining the different edges. So if we join different edges, A2 dash, B2 dash, C2 dash, D2 dash and E2 dash. So you can see A2 dash, E2 dash has been drawn as a hidden line. E2 dash, D2 dash is also drawn as a hidden line because it is no longer part of the boundary of the solid. Similarly, O2 dash, E2 dash will also be drawn by using a dotted line because it is not constituting the boundary of the solid. Rest everything should be drawn as an object line. So all the edges, they have been joined appropriately. You can see A2 dash, B2 dash, C2 dash, D2 dash, E2 dash and A2 dash, and then O2 dash, A2 dash has been joined solid. O2 dash, B2 dash has been joined solid because it is the boundary. O2 dash, C2 dash has been joined using object line. O2 dash, D2 dash has also been joined using object line. And finally, I can join the axis line. The axis line is O2 dash and O21 dash. So this way, we have completed the construction of the front view projections as well as the top view projections of this particular oblique pentagonal pyramid, which is resting on ground on one of its corners of its base, while the opposite triangular slant face, it happens to be parallel to the horizontal plane, and the edge of the slant face, which is containing the base edge, which is opposite to this particular corner, that is A1, B1. So this is further inclined at an angle of 60 degree with respect to the vertical plane. So with this, we have completed the discussion regarding construction of orthographic front view and the top view projections of this oblique pentagonal pyramid, which happens to be inclined with respect to HP and inclined with respect to VP. So I hope that through this discussion you would have understood about the procedure to evaluate orthographic projections of the oblique solid in this particular case. So we will be continuing with the further discussion regarding the projections of the oblique solids in the coming lecture discussions as well. So this is all for today. So thank you very much. Thanks a lot.